Hey guys, sorry I can't be there today. Go ahead and take out your homework assignment from last class. You remember the one, compound interest. It should be completed for computing $10 at 4% and $10 at 8% for years 1 through 8. You'll need a calculator and a pencil and perhaps even more paper today. Okay? Of course, this is the assignment I'm talking about, and you should have the 4 years filled in, the 6 years filled in, and of course 1080 at 8% for the first year, and then so on and so on. And of course below showing all of your math work. Now, when we did this particular assignment, in order to find how much money $10 would turn to in 6 years, we had to do 6 different calculations. Time consuming, and I know we're all short on time. So, believe it or not, we have a formula we can use. And here is our formula. A is equal to P 1 plus R to the power of T. Whew, that's a lot of stuff, so let's figure out what all these things mean. A is the amount that you'll end up with. P is the principal, the original amount you start with. R is the interest rate, as always, expressed as a decimal, not as a percentage. And T is the number of years that the investment amount is compounded. Now, if we take our formula to the assignment we did last class, let's go, oh, look at that, it's already written up there. Let's see how this works here. There we go, the calculator's out. Now, if you borrow one of my calculators, it's not going to work because it doesn't have the to the power of function, but let's go ahead and look at it. Let's say again we start off with $10 for 6 years at 8% interest, and before it took us 6 different calculations to do that, let's just do it with this formula. So the first thing you have to do is 1 plus R, or 1 plus 0.08, and that of course should be 1.08 to the T power. Time in this case, let's do it for the last one, 6 years. So y to the x button on your calculator, 6 equals 1.586. And then times, the last thing, we times it by p, or the original amount we started with. In this case it was $10 times 10, and that equals 15.868. We'll round that to 1587. Oh my, there it is. So with this formula, we don't have to go through a lot of calculations. We just have to put in the formula for how many years. Obviously, it's easier, it's quicker. You just can't have a simple calculator to do it. You have to have one with to the power of function on it. So let's go ahead and perhaps partner up with somebody who has a fancy dancy calculator that come from my desk area. And let's do these 3 problems. Let's say Randy H. invests $500 today in an account earning 7%. How much will it be worth in 5 years, 10 years, or 20 years? Okay. Again, we will take 1 plus, in this case, 7%, or 0.07. That gives us 1.07. Yx to the, we'll do the first one, 5 years. And multiply that by the original amount, which would be times 500. And we end up with $701.28 for the first one. So go ahead and do, here's 10 and 20 years there on your own, together with a partner, or 3 or 4, whatever it takes. And let's see how you do. Okay, so hopefully you got those done. Let's go ahead and share. Let's make sure we're all on the right track for the 10 years and 20 years. And let's try it just one more time. We'll let you do these 3 on your own. Now let's assume that Randy finds an account that earns him 10% interest per year. How much will his $500 be worth in 5 years, 10 years, and 20 years? Now, just take a few minutes to get those 3 answers. Okay, so I hope we did that correct, and you guys all understand how that works. Just a little easier way. Just need a little better calculator to do it than what we've been working with. Okay, we're going to move on to the rule of 72 now. And I believe this rule actually was developed partly by Albert Einstein, the rule of 72. And basically all it does is it shows how long it takes to double your money if you know what interest you're getting. Now the weird thing about this rule of 72, it's not exact. It's not an exact science. It shows approximately how long it's going to take. Not exactly, just approximately, so it gives you a good idea. And all it is you take 72 and divide it by the interest rate you're going to get. So, for example, if you have something earning 6%, didn't mean to do that, 6%, and all you do is take 72 and you divide it by 6. Now, the weird thing about this formula is, not only is it not exact, but you don't take the interest rate and turn it into a real number. You just keep it as 6. You don't change it to 0.06. So you take 72 divided by 6, and your money will double in 12 years. So if you have $5 earning 6%, in 12 years it will turn to $10. If you have $100 earning 6%, in 12 years it will turn to $200. If you have $1 million earning 6%, in 12 years it will be $2 million, excuse me. So, and that's approximately 12 years. It's not exactly, it's approximately. It's pretty close. Okay? Now, if you have something earning 9%, again, just take 72, divide it by 9. Don't change the percent to a real number. Approximately, it will take you 8 years to double your money. So, 1 quarter becomes 50 cents in 8 years. $10 million becomes $20 million in 8 years. Okay? So just an easy way to figure out how long it will take for your money to double at a certain interest rate that you're getting. Okay. Obviously, if you're earning 1% interest on a savings account, 72 divided by 1 is, hope you got that one, 72. It will take you 72 years to double your money in a savings account earning 1%. Okay. Now, if you have a time limit, let's say you go, ooh, I need to double my money in a certain amount of time. It works the same way. You take 72 and divide it by the amount of time. Now, when we talk about time, we always talk about years. Okay, so let's say you have 10 years that you have to double your money. So you need, you've got 10,000, and within 10 years you need 20,000. What percent interest do you need to get your money doubled at that rate? Now, 72 divided by 10 is 8, or you need an investment that gets you 8% back if you want to double your money in 10 years. Okay, and again, this is approximately. It's not exact. It's approximate. It's pretty close. Okay, so the rule of 72 works both ways. 72 divided by an interest rate, or to get you how many years it takes, or 72 divided by time, or the years, to get you what interest that you need. Okay. All right. Ooh, shows a quiz down here. We'll do that when I come back. Okay, so now we're going to hand out a worksheet there with some compound interest problems, some rule of 72 problems, and good luck, you guys. If you have any questions, hopefully everybody will be healthy in my family tomorrow, and I'll be able to make it back to work, and I will help you out with any of your questions. Always use the Scott Center. Take care.